Welcome to my short lecture on the subject Smart Cities and Communities. Today we will be discussing module number 7 of Unit 3, that is e-ticketing. 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 E-ticketing is a concept that is coming under intelligent transport systems. All of us must have traveled somewhere or some far places, and either by taking bus services or by taxi services or by airport services or by rail services, or we must have traveled on our individual means. Mostly if you are traveling by public means, then usually if you are traveling in a bus, it's a standard procedure to issue a ticket. Instead of having a hardware ticket, in terms of paper ticket, it is always better to issue an electronic ticket because of so much benefits that you are going to get from issuance of such electronic tickets. And this is an efficient method of ticket entry, and it is easily processable, and it is easy process for commutation, either in the airline, railways, or transport, and even in the entertainment industries. Now, for example, if you are getting an e-ticket for an air transport, what are the various things that the electronic ticket may contain? First thing that it will have is an official ticket number. It may have some 3-digit or 4-digit codes or a 6-digit serial number, and it must have some carriage terms and conditions, and it must be having fare and tax details and some short summary of fare restrictions if applicable, and if you will be able to get a refund and the penalties if applicable. All these things will be specified in the ticket, and what mode of payment you did, what is the issuance office, and how much baggage you are supposed to carry for that transport. All these things will be specified in the airport e-ticket. So why do you need to go for this e-ticketing rather than paper ticketing? It is cheaper, especially for airline, and no piece of paper we need to carry that may get displaced or misplaced, and it is a well-designed system. The processing complexities are reduced, and it is easy to keep records and less chance of ticket theft, and airport check-in processes may get simplified, and it is easy to purchase and print an e-ticket anytime 24 hours a day, and we need not stand in a queue line to obtain this ticket. We can simply be in our workplace or home, and via a credit card or online payment system we can pay for the e-ticket. But regardless of whatever may be the benefits, the disadvantages are, suppose if you are a nostalgic person, then we will not be able to have a souvenir ticket to paste in a scrapbook, and if in case system in which you are carrying the e-ticket fails or it gets crashed, then you will not be able to access it if you are not having a proper backup. With this, we will close the session. Hello and welcome to my short lecture on the subject Smart Cities and Communities. Today we will be discussing module number 2 of unit number 3, that is environmental aspects of intelligent transport system. So transportation system will become efficient if you are able to incorporate some individual intelligent technologies into them. And in addition to increasing transportation efficiency, this may reduce congestion, and this may have a huge impact on environment also. It also offers solutions that address growing concerns about urbanization and climate change. So let us check out what are the benefits that are offered by adopting such intelligent transport systems. The first and the foremost thing is to reduce emissions. Intelligent transport system helps in reducing traffic congestion and this will in turn reduce fuel consumption, and this again will reduce the emissions. And if you are having a smart traffic management, if you are adapting adaptive traffic signals, then it will reduce the standing idle time at intersections or at traffic signals, and this will again improve the air quality. And if you are encouraging more people to use it by enhancing the technology, enhancing the reliability and convenience, and this will improve more people, or this will make more people to use public transits. And instead of existing vehicles, we can use electric vehicle infrastructure, and this will contribute to reduced reliance on fossil fuels. Now let us check out what are the technologies that may have such a huge environmental effect. And the technologies include vehicle to vehicle communication, vehicle to everything communication. And if we have such advanced technology options, that it will effectively improve traffic flow and it will reduce the emissions. And if you are helping the drivers by real-time traffic data to take routes that will have minor congestion, and this will reduce their travel time, and this will reduce again fuel consumption and in turn fuel emissions. And instead of self-driving vehicles, if you are going for autonomous vehicles, then intelligently it may think of some efficient driving pattern, and this again will reduce low emissions. And suppose if you are able to, by the use of technology, if you are able to encourage the public users to go for eco-friendly driving behavior, then again this is an additional thing that will have a huge impact on environmental. And air quality management by ITS is very important concept, and for this you may install some air pollution monitoring sensors and traffic flow optimization tools. And with the integration of these things into the existing transport system, we may be able to have less pollution, less emissions, and this will improve existing air quality. And just by having optimized route planning and eco-driving assistance, if you are able to provide these to the drivers, then they will be able to efficiently reduce the fuel consumptions. And instead of electric vehicle, if you are instead of existing common vehicles, if you are going for electric vehicle, and if you are able to integrate them into smart grids, then it will help in balancing energy demand and supply. But still, if you are including technology into the existing transport systems, there might be some challenges. The first challenge is, suppose if you want to make the transport infrastructure intelligent, then it really includes the inclusion of some sensors and cameras, etc. And this will require significant financial investment. And if you are making the transport system to think in an intelligent way, then this may raise some data privacy concern, and still the public are not aware about the existing technologies. And this may, in order to make the public buy into the technologies, it may take some time. And there are some technology limitations also. Some of the advanced technologies are not still accessible to some areas. With this, we will close the session. Hello and welcome to my short lecture on the subject Smart Cities and Communities. Today we will be discussing module number 6 on Unit 3. That is GPS, Global Positioning System. GPS is actually Navstar GPS, that is Navigational Satellite Timing and Ranging Global Positioning System. It's a space-based satellite navigation system which provides information regarding location and time, and it is developed and maintained by USA, and it is open access. Anyone with the GPS receiver will be able to access the information, and it basically consists of 30 plus GPS satellites in medium Earth orbit, and in order to gain information, at least 24 satellites which are working in harmony should be available, and this is called a satellite constellation, and many uses are possible with GPS. Some are navigation, map making, surveying, and meteorology. The GPS scheme actually has 3 segments: space segment, control segment, and user segment. Space segment is nothing but the satellite section where GPS satellites are flying in circular orbits, and they are powered by solar cell, and their antenna point towards the Earth, and orbits are so designed that at least 6 satellites are always kept within line of sight from any location on the planet. Next comes your control segment. Control segment has 3 entities: master control station, monitor station, and ground antenna. The master control station is located at Falcon Air Force in Colorado Springs, and it is responsible for overall management of the remote monitoring and transmission sites, and its basic use is to reposition satellites to maintain an optimal GPS constellation. Apart from this master control station, there are 5 monitor stations located in all these places, and their work is to check the altitude, position, satellite, and overall health of the orbiting satellites, and this ensures the GPS satellites' orbits and clocks remain within acceptable limits, and a station is capable of tracking 11 satellites at a time, and checkup is to be done by all these places twice a day by each. And in addition to this, you are also having ground antennas, and the basic function of these ground antennas is to monitor and track the satellites from horizon to horizon, and they are capable of transmitting correction information, command and control purpose to the individual satellites. And finally, user segment. It is present in our individual cars, GPS receivers, or in our mobile phones. We are having GPS receivers, and these GPS receivers are composed of an antenna. The antenna is tuned to the frequency transmitted by the satellites and processes a stable clock, which is nothing but a crystal oscillator. Additionally, we will also have a display for showing the location and speed information, and a receiver usually has between 12 to 20 channels. This is signifying how many satellites it can monitor simultaneously. So this is your pictorial representation of the entire GPS system, starting with your space segment, that is the satellite segment, and then you are having monitoring stations that are located on Earth, and finally this is the GPS receiver, that is your user segment. Now, next comes your working principle. How actually the signal is located, or how actually the target is being located. It is done by a geometric principle. So the basic information that is to be determined is the distance between these GPS satellites and the receiver. Then the first thing that is to be determined is the positional information of all the GPS satellites, that is actually stored in an almanac. Now the next thing that is to be determined is what is the distance between receiver's position and the GPS satellites. So to get this distance, the first thing that is to be done is you have to transmit a radio signal between these 2 items, that is the GPS satellite and the GPS receiver. Now there is a formula where the distance is calculated. We are to Take the product between the speed at which the radio waves travel and the time it takes for the radio signal to travel from the satellite to the receiver. Take the product, it will give you the distance. And the distance is accurately determined by the principle that is called as trilateration. So, the distance measurements from two satellites. As you can see in the picture, two satellites are involved. From two satellites, the information is gained. Then the intersection between these two spheres, the location is given actually as a circle. So third measurement is to be done in addition to this. Now there are three satellites that are involved, and now the position is made accurate to 2 points. And a fourth measurement now, which makes use of at least 4 satellites, and now the true location of the target is achieved as a single point. So this accuracy, if you want to gain, means at least, as you can see from the picture, minimum 4 satellites ought to be involved and 4 measurements ought to be done. And the worst case accuracy is 7.8 meters and 95% confidence level. The time accuracy is about 14 nanoseconds. And in case if you want to improve the accuracy further, then augmentation systems are to be involved, and this will enable real-time positioning within a few centimeters, and these are different GPS frequencies and the function for which it is being used. Now, how the GPS system works. Okay. First, the device, that is a GPS receiver, should be installed within the vehicle, and the device will be located by the satellite using GPS, and the GPS value will be sent to the server via general packet radio services, and the server will be storing the data for 365 days, 1 year, and whenever you want to require the information, you ought to just log in on. Now, GPS is actually was actually developed and maintained by USA. Now, from Indian perspective, what are the things that are actually in development for you having this user requirement satisfaction regarding position, navigation, and timing services? ISRO and Airport Authority of India have established Gagan system. Gagan is nothing but GPS-aided geo-augmented navigation system. And ISRO is also establishing a regional satellite navigation system called Indian Regional Navigation Satellite System. The reason why this GPS we are discussing is, it is part and parcel of ITS, that is Intelligent Transport System, and it enables automatical vehicle location and in-vehicle navigation system, and this is also part and parcel of Geographic Information System, and this can display geographic information with systems that can automatically transmit data to display screens or computers. That is the new dimension in surface transportation. And using GPS technology, you can help track and forecast the movement of freight, and time-definite delivery is possible. Time-definite delivery means the trucking companies will be able to track the trucks to guarantee delivery and pick up at the time promised. And this GPS can be installed in a smart mobile device from which you can locate your vehicles, and it can also help drivers to plan assignments and manage costs. And important 3 fields of ITS in which the GPS can be applied is automatic vehicle location, general fleet operation, and dynamic route guidance. What are the benefits of GPS? Higher levels of safety and mobility for all the surface transportation system users, and accurate position determination, better location information with eMaps, and this will give you passenger information. It can also provide in-vehicle navigation system both for private and commercial users, and it is also used for effective monitoring, schedule adherence, and it also makes the transit system more responsive, and increased efficiencies and reduced costs in surveying roads. the main limitation of GPS is signal loss. In order to get a signal at least between the GPS antenna and the 4 or more satellites, there should be a clear line of sight, otherwise it will be giving out inaccurate data. And another problem is GPS signal may bounce off nearby objects, causing multi-path interference. With this, we will close the session. Hello and welcome to my lecture on smart cities and communities. We will continue up with module number 5, that is on unit 3. The topic is GIS, Geographical Information System. Now, what is GIS? It is nothing but a powerful framework that captures, stores, analyzes, manages and visualizes geospatial data. It links the physical locations on Earth with its descriptive information, and it helps users to identify spatial patterns, trends and relationships. Now, if you look into the key components that are present in a GIS, first one is the hardware. So you require a computer, server and scanner to run the software. Now comes the software. It is nothing but program that is used to input, store, query and analyze this geospatial data. And then comes the data itself. Now data is actually classified into 2 categories. One is in vector format, that may be a point, line or a polygon, or in raster format in the form of satellite imagery or grids, and they are provided along with their attribute tables. And then the people who work on this data, they are the trained analysts, cartographers, that is map makers and technicians who design these workflows, and they are the ones who interpret these spatial models. And finally, the methods. This involves the specific analytical process and workflows used to solve the real-world problems. Now, what are the capabilities of this GIS? First one is data integration. So it's one that combines completely different types of information. Suppose if you take the case of property, it will include the property elevation, property boundary and its demographic data, all being integrated together into a single map. Next is the spatial analysis. The layering techniques are used to calculate the nearness, the model routes and to assess the environmental risks. Next, the visualization. So you want to visualize all these data. So for that, a dynamic 3D map along with interactive dashboards are also forming part and parcel of GIS. The different applications that we are using and in which case we are to need GIS is urban planning and logistics, disaster management and agriculture. The various potential applications, if you consider very many numbers, is listed as shown in the slide: highway maintenance, traffic modeling, accident analysis, route planning, environmental impact assessment of road schemes, executive information system, pavement management system, bridge management, maintenance management, safety management, transportation system management, travel demand forecasting, corridor preservation, right-of-way, construction management and many others. Let us see some of the potential applications. First let us discuss planning. We are having different transportation agencies. They always have a challenge of keeping their infrastructure operating smoothly and efficiently. So suppose if you are integrating a travel demand forecasting package with the GIS technology, this will help transportation professionals make complex analysis in order to plan the transportation systems of the future. Then, transportation planners using GIS, they can take into account land use, environmental, greenhouse considerations, along with energy consumption factors into the planning process. If all these factors are brought together along with the GIS, this will help in the comprehensive planning model, and this will in turn help effectively plan the future. So, design. GIS helps bringing out data in form of imagery, elevation, and environmental information is also integrated into the CAD environment. So engineers can continue working with the familiar software and while they are gaining access to GIS data. And GIS is thus an essential component of the engineering information systems of the future. For traffic engineering also we will be we can use GIS, especially for congestion management programs in highways. The highway base maps, attribute databases, long-range transportation planning in urban areas. For this, the highway base maps and attribute databases are very, very necessary, and this can be brought out by GIS. Traveler information system. The public should be provided with current information on the traffic conditions. In case if there is any problem, they should be able to switch on to other alternative travel options. And this information is obtained actually from various sensors, information choices. So using GIS, we can have a single source of up-to-the-minute travel, a journey planner for public transport, car sharing, bicycling, parking availability, all put together into a single application. Then safety management. Suppose if you are integrating or if you are analyzing accident data coupled with roadway features, traffic volumes, bridge inventory and other data, this will be very useful to develop safety management system. Bridge maintenance. By doing one simple query, we will be able to know whether bridge condition is functionally deficient or it is okay, what is the capacity distribution of those bridge, clearness, average daily traffic on the bridge. All these can be made known while you are passing through the area using GIS. So apart from these applications, we are having other applications also, and because of all these potential applications, the concept of geographical information system is very, very essential in the field of intelligent transport system. With this, we'll conclude the session.